So lexical closure. This is again something, a new keyword or terminology that you'll come across here in Scala. The same way like lambda expression or anonymous function, you might be hearing for the first time. So here, before explaining this, I'll simply show you an example. Just try to understand this by example. Okay. So I have a function fun1. Let me take this into my notepad. Okay. Or Eclipse. I don't need this much of space for this. Okay. Now what I'm trying to do here is, I have a function fun1. It is not taking any parameter, but returning a function. Okay. And what is that function? So inside this definition body, I have declared a one local variable, local constant y, and def add x colon int equal to x plus y. Is it something strange in Scala that you are observing here? If you have, if you remember the basic functionality of Java, if you try to, let's say I have a function main and println public void println print hello string message. Anything that I have outside of this function inside my class, okay, private int I equal to 10. Just simply try to do that I as well. Okay. So the way you are accessing your outside field inside, this field is within the scope of this function. Okay. I is defined just before the print hello. So that's the reason, even though I didn't pass that I as a function parameter to this, I'm still able to access this. Int test.java I'm able to access that I. Okay. Yep. Like class variable. Yes. So you have, that means not just the parameters that you pass to your function and not just the parameters that you declare inside your function. Any variables that are declared outside of your function, and if they are within the scope of your function, you can access them inside your function. Okay. Accessing message inside your program is not a big deal. Nothing surprising here. And int j equal to 20, and accessing this j is again not a big surprise. And I, which is not present, not passed as a parameter and not declared inside this variable, but if it is available within the scope of your class or this function, you can access this. Okay. The same way in Scala also. So here this add function, it is taking only one parameter x int, and using that x is nothing surprising, and y I didn't declare as a new field, but I am able to access this y value since this val y is available just declared before this function, and it is available at the time of execution of this function.
So you mean it's just like a global variable that can be used inside function?
Not a global variable. I mean, we should not say that that is a global variable. If that variable is available at the time of writing that, defining that function, you can see here in Java you have private variables. Okay, you declared it as private. It is not a global variable, but this variable is available for all the functions. In your point of view, this is global to this class.
Yeah.
Okay.
So this is global to the function one.
Yep. Global to that function one. And here, anything that you declared before you define your function, val y equal to 1, that is available, that can be used inside your function definition. Def add of x plus y. I just said x plus y. My y at this point of time, the only available y is this y. Okay, and if I print println of add of 10, so it should print something. This will not get executed first of all. If I only call this function, then only I will be able to execute this. Let's do that as well anyway. Not a big deal. There is some error, seems like somewhere. Function 3. Function 2 of integer. So what's the big deal of it? Having that's the problem while writing in this. You have to make sure that you're using new function names at the time. Okay. Now, please try to focus on this and try to understand. So I have function f1. Inside that I have an add function. Okay, and add function takes only x as parameter, but it does x plus y, and that y is 1 here. And when I println of add of 10, let's not worry at this moment what it prints here. Obviously 10 plus 1, 11. Okay, and now you are returning that function name at the end. That means whoever calls your function 1, they will get this add function to that. Now inside your function 3, you have val y equal to 2. Okay, and val f function 1, and if you call now println of f of 10, so this is nothing but val f is having add function, correct? Val f is having a reference to this add function. Add function means take x and return x plus y, and at the time of execution it has x as 10 and what is y? 2. But is this y local to this method, or this y it accesses? Just give it a try. Anyone wants to answer?
Yeah, y equal to 1 because it's declared outside of that function 1.
Y equal to 1 will be considered. The reason is
okay. Can you go to Eclipse, please?
Yes. I'm little bit confusing there because of this font and these things. I'm feeling like this is much better, isn't it? The shell. Let me increase the size maybe. Okay. Is this not good for looking, or?
Right, this is okay.
It's good for it's visible now.
Yeah. So it's better than that Eclipse, right?
Both are same. There's so much difference.
Okay. I mean, because of this too many boxes and things.
Yeah, I would prefer the command line. That looks very
Yeah, simple. Okay. So now I have this def here. So this function 3, inside this function 3, val y equal to 2, val f equal to fun 1, which means this has f is equivalent to add, and f of 10, add of 10, you are passing add of 10. Now, so whether it will print 11 or 12, and y. Function 3, I'll simply call it. So it printed both the cases 11, 11. The first got executed. So when you are calling f of 10, it goes to this call add of x plus y. First it calls while it gets the f, you are making a call to fun1, which means it goes here and y gets assigned to 1 and add function and println of add of 10 and add will get returned to f. So that's when the 11 got printed. And next time, again that add of 10, you are calling this directly add of 10, and it has the scope for accessing y only. This will not consider this y. So just one conclusion. The function fun1, this whatever this function, this returns a closure. A closure is a function, a nested function that is accessing not just its parameters, any of its local accessible variable, and that access gets carried over wherever it gets called, no matter. So at the time of definition, what was the variable it was accessing, that value will only be available throughout its execution. So no matter whether I call it from function 2 or function 3, function 4, function 5, it always uses that value y equal to 1 only, because that was the value of y at the time when we declared add function. Is it clear? Confusing? Is it clear or confusing? Or is it making sense?
Yeah, it's okay. It's not clear, but okay.
I mean, I'm not okay with your answer.
I don't want to lie. It's okay. It's clear. I mean,
No.
How much I'm able to grasp, I think I'm good.
No, I'm not telling you to lie. If you are not clear, I'm not okay. I will again explain. I mean, that's what.
I think actually I'm able to get it, but I'm not unless until I actually physically try it. I don't think I'll get confidence that I know this. But yeah, you can go ahead. No worries.
Uh,
But I'm not confident in what you said. I heard it, but I didn't grasp it actually.
okay. See, simple funda.
Hmm.
When you are using any inner functions or nested functions,
Yeah.
other than the function parameters, if you are accessing any other variables, whatever the variable value that was available at the time of writing, whatever the value that was available, that will only carried wherever you call that function, no matter where you are calling from.
Okay.
Okay.
Yeah.
See, at the time of writing my add function, my value of y is 1. No matter from where I call this add function. That's it. That always y is 1 only. Whether
Okay, so it's fixed. You have made it, and okay. Understood. Okay.
because at the time of writing, at the time of defining, what was my value? My y as 1. That will only be used wherever you call. That's a simple statement to you.
Okay. So in sense, if you are saying that the function one is calling another add function, and so basically it's function into function. That's it, right?
Function into?
Function in a function.
Yes, function in a function, that's for sure. But here this nested function is called a closure.
Okay.
Lexical closure. When we call that as a lexical closure, if you access any parameter that is not, I mean, if you access a variable which is not a parameter to your function and not defined inside yourself.
Okay.
Example, here we are accessing y. Y is not a parameter to add function, but you are accessing from this scope. Since you are within this method and you can access all the variables inside this method, you are accessing it. Now,
Okay. Get you. Yeah,
becomes
it's
closure.
much clearer now. Yeah.
Add becomes a closure, and closure context will carry forwarded wherever you call that. The same context will be maintained. Y will be always 1.
Okay. Okay.
Okay.
Yeah.
Yep. Now you see simple examples or usage of this. Let's say I have a variable called voting age. Okay. I declare my voting age, or if I have to put it in simple problem and the solution for that, if I have to calculate, calculate whether a particular user age is greater than, I mean, whether he is eligible for voting or not, you should need to write a function. So typically we write this way, like age and voting age, right? Age is of int and voting age is of int, and inside your function you check. So what will you write if age greater than voting age? Then return true. Okay. And every time when you are calling function 1, so if I'm calling my age 30, 18, then it returns true. And if I have to call someone else's age 16, 18, so every time I have to pass this. Okay. So instead of this, so what it is telling is that with the help of the closure concept, accessing the local variables, where voting age equal to 18, I define this one. I mean, I declare this Now I define is voting age or not. Another function, def is a voting age, just it takes an integer, it returns just a true or false. Okay. Age greater than voting age. Now if I call this is voting age of 16, the same is voting age of 32, and is voting age of 30. So no matter, I don't need to pass the second parameter. And again, if you, for a different scenario, if you want to change this value, you simply just change that voting age. Since you declared that as a voting age as var, and if you want to make it as 21, you can even keep this just changed one time, and you have your other method calls not impacted. So here, whenever you call this, your voting age context is, before you define that, so whatever the value that was there, if it is a val, that will get carried over the same. And if it is a var, and if you want to override that, you can. Okay. And similarly, you can see var more equal to 1, val add more of x plus more. Every time if you pass x, 1 will get added to that. And if you make, if it is a more is a variable, and if you change that more, and if you add this will get changed. And if it was a val, always 1 will get incremented. Okay. And another simple example is remove low scores. So what I'm trying to do is, this is a function which takes a list of integers, and I'm specifying a threshold. It's a list of scores. This is a list of scores, and I'm specifying the score threshold. Let's say cutoff is 35 or 60, something. If I specify the cutoff 60 here, and the return type is also another list of scores, and what I'm doing here, that the scores list A dot filter score, for each score in this list, return score greater than or equal to threshold. Now in this, I call this as a closure, because this is a body. A dot filter is the body of this function, remove low scores. Inside this body, score arrow score is an anonymous function, right? This is anonymous function, and in this anonymous function implementation, you are accessing a field threshold which is not a parameter of your anonymous function. If threshold is a parameter, then you should give this as a score comma threshold in a parenthesis arrow score greater than or equal to threshold. I doubt that half of you guys might not got this. This is the function body. Now, do you guys agree that this is an anonymous function? The highlighted portion of it. and this is anonymous function, and this is a nested function too, because this is a function inside the remove low scores function, defined inside a low scores function, isn't it? So score arrow score greater than threshold is anonymous function, because since there is no name for it and there is an arrow, that's why you are identifying it as a function, and since there is no name, you are calling it as anonymous function. And this anonymous function is present inside a body of another function, remove low scores. So this anonymous function got one more characteristic, that is, it is a nested function. Now you are adding one more characteristic. This is a closure. Reason? It is accessing not just its parameters, because if you take this as a parameter, this is your this is a function, this as a function, this is your input parameter, and this is your body. And inside your function body, you are using a new variable which was not a part of your input parameter list, and which you didn't declare also inside your body. You didn't declare this way, like a var threshold. You didn't do this, var threshold equal to 0 or something. You didn't do this. But you are using this within the scope of this. And I am talking about this function. So you are passing only score as parameter, but in the body you are accessing threshold also. From where it is accessing? From this method. Meaning your parent method, inside which you have got defined, or inside which you defined it. Now since it is accessing a threshold, since this is now called as a closure as well. Now, so it got all the names, whatever that we have discussed. This is anonymous function, right? And it is a nested function, since it is present inside that remove low scores. And this is also called as lexical closure, since it is accessing the threshold, which is not a parameter to this. And you will see this kind of usage a lot in Spark programming.
So when I call the score function, right? I don't need to pass the threshold value.
Yep. See,
yeah. So
I mean, first of all, there is no scope for you to call this function directly.
Yeah.
Because there is a no name for this.
Correct.
You always have to call remove low scores, pass a list, 25, 35, some marks, some scores.
Okay.
Specify threshold as 60, and inside this is a function that gets executed for you and filters out the list's values to it.
Okay.
Okay. If I would have given a name to it, and if I were returning that name, then you might call that function, and then you can directly call the score.
Okay.
So like we have seen in the previous slide. Here I have given a name, def add, and that add will get assigned to F now, and I'm returning that there. And even if you don't return here, I'm not even returning here score arrow score. This is an anonymous function which is defined inside this remove low scores, but I'm not returning a reference to this function anywhere. It simply gets executed. Even then, this is a nested function, and this is a closure.
Okay. Yep.
Okay. See, these concepts, little bit minor differences, might be a little bit confusing. Just try to
we can understand if it is a separate concept, but if it is inside a big program, or if we are doing some analysis, that's where we will get real pain, I guess.
Yeah. So I mean, you can do. I mean, while you are writing programs, you will be clear what you are trying to write.
Correct. Yeah.
When someone has written, and if you are trying to understand, if they might have used all these things, you should not get confused. That's the reason why I'm trying to give all these kinds of writing.
Yeah.
Okay. So if you are writing program, you can simply write whatever the concept, basic anonymous function concept, if you know just that level. I can even rewrite this way. I don't need to make this as a, I can simply pass both the parameters, and I can access them.
Yeah.
Then this is no longer a lexical closure.
Or we can define a threshold as one value, and
Correct.
then we can keep on checking whether it's
okay. Yeah. So you can achieve without lexical closure also the same functionality. Without declaring this as a nested function also you can achieve. You write this somewhere in the function def some filter fun and do this, pass these two parameters here and do that, and then you call this filter function. Then that time it is no longer anonymous function 2, and you have clear-cut understanding what you are doing.
Yep. Correct?
Yeah. So this is, until you guys get comfortable, everyone will do this one only, because since people come from different programming languages, if you are not not much expert into mix and use all these concepts, we were doing the same kind of stuff. I was defining a function regular to any Java function, passing parameters and returning, and taking that name and using that name only and wherever I want. Without using that anonymous functions concept also, I can achieve these things. But only thing is, you should not get confused in analyzing the existing code. And slowly, if you get used to usage of this, you'll find like you'll, instead of writing 3-4 lines of code, you'll write it in just 1 line. That's it. That's the beauty once you get perfect into the Scala program. Okay.